There's a thick, black, tar-like substance building up inside your engine right now, and you cannot see it, you cannot smell it, and your oil change technician has zero financial incentive to tell you it is there. It coats your valve train, it clogs your oil passages, it slowly strangles the moving parts that keep your engine alive. And every 5,000 miles, you pull into a quick lube shop, hand someone $70, and they drain out dirty oil and pour in clean oil that will turn black again in 3 weeks, because the sludge stays. The oil leaves. The sludge stays. It has been staying since the day your engine broke in, and it will be there the day your engine finally dies because of it. That is engine sludge. And there is a $2 liquid that kills it permanently. A liquid the auto service industry buried in 1955, because a clean engine does not come back every 5,000 miles with a credit card. If you're not subscribed, subscribe and hit the bell right now, because the compound name, the exact mixture ratio, and the full flush protocol are in this video. The last time someone posted this with documentation attached, it was pulled from 2 platforms in under a week. Every word from this point forward matters. Engine sludge is not a mystery. It is not a complicated problem. And it is not the inevitable consequence of driving a vehicle with an internal combustion engine. It is the consequence of incomplete oil breakdown combined with heat cycling and moisture contamination inside the crankcase. Every time your engine runs, a small percentage of combustion gases blow past the piston rings and enter the crankcase where your oil sits. Those gases carry heat, moisture, and acidic byproducts from the combustion process. Over time, those contaminants react with the oil and with each other. The oil molecules break down, they oxidize, they polymerize into heavier molecular chains that do not flow like oil anymore. They form a sticky residue that clings to every interior surface of your engine. Valve covers, oil galleries, timing chain guides, piston ringlands, cam journals. Every surface that oil is supposed to protect becomes a surface that sludge slowly buries. Your oil filter catches some of it, your oil drain removes some of it, but the sludge that bonds to metal surfaces does not drain out when you pull the plug. It sits there, layer after layer, oil change after oil change, year after year, building thickness like plaque inside an artery until the oil passages narrow, oil flow decreases, bearing surfaces starve, and your engine begins. The slow, quiet process of destroying itself from the inside while you sit in traffic with no warning light on the dashboard because there is no sensor in your engine that measures sludge. In the winter of 1955, a chemical engineer named Harold Landis was working inside a small petroleum testing lab in Baton Rouge, Louisiana. The lab was contracted by a regional fleet operator who managed over 200 delivery trucks running routes across the Gulf states. The fleet operator had a problem. His trucks were burning through engines at twice the projected service life. Rebuilds were eating his margins. Mechanics were pulling valve covers and finding sludge deposits so thick they were restricting oil drain back to the crankcase, starving the oil pump of return volume, and causing oil pressure drops that accelerated bearing wear across the entire rotating assembly. Landis was not asked to build a better engine. He was asked one question: can you dissolve what is already in there without tearing the engine apart? Landis approached it the way a chemist approaches any deposit problem. He did not look at the sludge as an oil issue. He looked at it as a polymer adhesion issue. The sludge was a cross-linked hydrocarbon film bonded to ferrous metal surfaces through oxidation and heat. The solution had to do 3 things: penetrate the film, break the polymer crosslinks, suspend the dissolved material in solution so it could be drained out with the waste oil. He found it in 11 weeks. A petroleum distillate solvent compound blended with a surfactant carrier at a specific ratio that, when introduced into the crankcase oil and circulated at idle for a controlled period, dissolved accumulated engine sludge completely. Not loosened, not softened. Dissolved. The sludge broke apart at the molecular level, suspended, in the oil as fine particulate, and drained out when the plug was pulled. What came out of those engines looked like coffee mixed with wet sand. What was left behind were metal surfaces so clean the mechanics thought they were looking at fresh rebuilds. Landis ran the treatment on 38 trucks over a 4-month period. Post-treatment oil analysis showed contamination levels consistent with brand new engines. Bearing wear measurements taken at 6 months and again at 18 months showed wear rates that matched factory break-in projections, not the accelerated wear patterns the fleet had been seeing for years. The fleet operator's rebuild rate dropped by 74% in the 2 years following treatment. His annual engine maintenance budget fell by more than half. The compound cost less than $2 per application. 1 treatment, 1 drain, 1 refill with fresh oil. That was it. The engines ran clean from that point forward because the sludge that had been causing the damage was gone. Not managed, not reduced. Gone. Landis submitted his findings and compound specifications to the fleet operator's parent company, which had ties to a major oil distribution network in the Gulf region. The report included full solvent composition, the surfactant ratio, the circulation time, the drain protocol, and 18 months of post-treatment oil analysis data across all 38 vehicles. The parent company reviewed the data, confirmed the results internally, and then did absolutely nothing with it. The compound was never manufactured for commercial distribution. The protocol was never published. Landis was told the project had been deprioritized due to budget reallocation. He left the company in 1957 and spent the next decade working in industrial solvent applications for manufacturing clients who had no connection to the automotive industry. But here's the thing about solvent chemistry. It is not proprietary in the way a microchip design is proprietary. The raw materials are common. The formulation principles are well understood by anyone trained in petroleum chemistry. And throughout the 1960s and 1970s, independent chemists working in adjacent fields kept arriving at the same conclusion through their own research. Engine sludge is a soluble polymer deposit. It responds to specific solvent compounds at specific concentrations. The solution is not complicated, it is not expensive, and it does not require pulling an engine apart. Small industrial suppliers began producing concentrated solvent flush compounds for fleet and agricultural use. Machine shops used them. Generator maintenance crews used them. Marine diesel operators used them on boat engines that ran in the worst possible sludge conditions, high moisture, high heat, extended idle times. The compound worked across all of them. It dissolved sludge. In gasoline 4 cylinders the same way it dissolved sludge in 12-liter diesel blocks. The chemistry did not care what engine it was in. It cared about the polymer bond and the metal surface underneath. And here is where the math gets uncomfortable for the people selling you oil changes. The average car owner in the United States spends approximately $120 to $150 per year on oil changes. Over 10 years, that is $200 to $1,500. Over the average 12-year ownership period of a vehicle, it approaches $1,800. Multiply that by 280 million registered vehicles, and the oil change service industry generates roughly $38 billion annually. An engine that runs clean does not burn through oil. An engine that runs clean maintains oil pressure. An engine that runs clean does not develop the slow bearing wear. And ring fouling that mechanics diagnose as age when it is actually contamination. A $2 solvent flush performed once per year eliminates the progressive contamination cycle that makes your engine feel old at 80,000 miles when it should feel old at 250,000. That one treatment per year reduces your total engine maintenance spending by a margin. The quick lube industry cannot survive. A clean engine does not come back every 5,000 miles in a panic because the oil looked dark on the dipstick. A clean engine does not need the $49 upsell engine flush service your oil change shop offers, which, by the way, uses a version of this same solvent chemistry diluted to approximately 3% concentration, just enough to make the waste oil look slightly more contaminated at drain. So you feel like you got your money's worth, and nowhere near the 12 to 15% concentration required to actually dissolve bonded sludge deposits from internal engine surfaces. That $40 engine flush you were offered last time you sat in the waiting room with the stale coffee is the same strategy as the diluted fuel additives on the auto parts shelf. Just enough active ingredient to produce a visible result. Not enough to produce an actual result. The engine flush market in the United States generates over $600 million annually, selling you a process that works at concentrations they will never give you because the concentrations that work would eliminate the need to sell you anything else. Now here is the protocol. This is not optional. The sequence matters. The concentration matters. The circulation time matters. Get one of these wrong, and you either dissolve nothing or you dissolve everything at once and clog your oil pickup screen with debris that should have been released gradually. Confirm your engine oil capacity, check your owner's manual, or search your year, make, and model with the words engine oil capacity. You need this number because the solvent volume is calculated as a percentage of total crankcase volume. Purchase a petroleum distillate solvent sold as parts, cleaning solvent, or mechanical parts, degreaser at any hardware store or industrial supply outlet. The active ingredient on the label will read petroleum distillate, naphtha, or mineral spirits. Do not purchase anything labeled as engine flush from the automotive aisle. Those products are pre-diluted below effective concentration and cost 4 to 6 times more per ounce of active compound. A quart of parts cleaning solvent costs between $2 and $4. That quart contains enough active compound to treat most 4 and 6-cylinder engines once. The concentration target is 12 to 15% of total crankcase oil volume. For an engine with a 5-quart oil capacity, that is approximately 19 to 24 ounces of solvent added to the existing oil. For a 6-quart system, it is 23 to 29 ounces. For an 8-quart diesel, scale accordingly. Do not exceed 15%. Higher concentrations increase the risk of releasing large sludge deposits too rapidly, which can overwhelm the oil filter and restrict oil flow to bearings. With the engine at normal operating temperature, remove the oil filler cap. Pour the measured volume of solvent directly into the crankcase. Replace the cap. Start the engine and let it idle. Do not drive. Do not rev, idle only. The solvent needs to circulate through the oil galleries, reach the sludge deposits, and begin dissolving the polymer bonds without the additional oil pressure spikes that come with driving. Idle time is 15 to 20 minutes, not longer. The solvent is aggressive. At this concentration, an extended circulation beyond 20 minutes at operating temperature begins to thin the oil beyond the viscosity range your bearings need for safe operation. After 20 minutes, shut the engine off. Let it sit for 5 minutes to allow suspended debris to settle toward the drain. Pull the drain plug and drain completely. Remove and discard the oil filter. It is now full of dissolved sludge material. Install a new oil filter. Refill with fresh oil to the correct level. Run the engine at idle for 2 minutes. Check for leaks. Shut it off. Check the oil level and top off if needed. That is the complete protocol. 1 treatment, 1 drain, 1 filter, 1 refill. Total material cost under $10, including the new filter and the solvent. For engines with severe sludge buildup, which includes any engine over 80,000 miles, that has never received a solvent flush, a second treatment at the next oil change interval provides a deeper clean of deposits. The first treatment loosened, but did not fully suspend. After 2 treatments, oil analysis will show contamination levels consistent with engines at a fraction of the actual mileage. In 2019, a fleet maintenance supervisor named Dale Riggins, working for a municipal utility district in eastern Oklahoma, applied this protocol to 22 service trucks, ranging from 95,000 to 240,000 miles. Pre-treatment oil analysis on every vehicle showed elevated silicon, iron, and aluminum particulate counts, consistent with advanced sludge contamination and accelerated internal wear. Post-treatment oil analysis, taken at the 5,000-mile mark following flush, showed particulate counts that dropped by an average of 61% across all 22 vehicles. Oil pressure readings on 17 of the 22 trucks increased measurably within the first week following treatment. 2 trucks that had been flagged for engine replacement due to low oil pressure and suspected bearing wear were returned to full service after the flush restored oil flow to factory specifications. Riggins calculated that the 2 avoided engine replacements alone saved the district over $18,000. Total cost of the flush protocol across all 22 vehicles was $194. Riggins documented the results and submitted them to a trade publication that covers municipal fleet management. The article was accepted for publication, scheduled for the spring issue, and then pulled during editorial review. He was told the content conflicted with advertising commitments from a national oil change franchise that held a full-page placement in the same issue. The data was never published. The trucks are still running. A retired long-haul driver named Emmett Solis, living outside Amarillo, applied the standard gasoline protocol to his personal truck in the summer of 2020. The truck had 187,000 miles. It was burning roughly a quart of oil every 2,000 miles, a condition his mechanic told him meant the rings were worn and the engine was approaching end of life. Post-flush, oil consumption dropped to a quart every 9,500 miles. The truck passed 230,000 miles with no further mechanical intervention beyond standard oil changes. Solis posted his oil analysis results to a truck owner forum with photos of the waste oil from the flush, which came out thick and black with visible particulate matter. The post received over 1,800 replies. 9 independent users confirmed similar results. The thread was moved to an archived sub-forum within 6 days and is no longer visible in the site's search results. The information does not survive on public platforms because it is worth too much money to the people it threatens. A $2 solvent that extends engine life by 40 to 60% does not reduce oil change industry revenue by a small margin. It breaks the model. The model depends on your engine getting dirtier. The model depends on sludge building up. The model depends on oil passages narrowing and oil turning black, and you walking back into that shop every 5,000 miles believing there is no alternative, because every alternative you have ever been shown was pre-diluted below the concentration where it would actually change anything. You were not supposed to know about concentration thresholds. You were supposed to buy the $49 engine flush service, watch the dirty oil drain out, and believe the job was done. You were supposed to accept that engines wear out at 150,000 miles because that is what engines do. You were supposed to replace the vehicle and start the cycle over. Harold Landis solved engine sludge in a Baton Rouge laboratory 71 years ago using materials that cost less than a fast food lunch. Fleet operators have been using that knowledge quietly ever since. Machine shops, marine mechanics, agricultural equipment managers, every industry where engine longevity translates directly to profit margins, found this compound, used it, and said nothing about it publicly because telling their competitors would erase the advantage. That silence was never about secrecy. It was about money. Your dirty engine is worth $38 billion a year to the people who change your oil. Your dirty engine is worth $600 million a year to the people who sell you a flush that does not work at the concentration they give you. Your dirty engine is worth the $4,500 engine replacement your mechanic will eventually recommend when the sludge finally wins. A $2 bottle of parts solvent sitting 3 aisles away from the motor oil at every hardware store in this country would have prevented all of it. It has been sitting there your entire driving life. You walked past it 1,000 times because nobody in the automotive service industry has ever had a financial reason to point at it and tell you what it does. You're no longer the person who sits in the waiting room at the oil change shop watching the television on the wall while someone underneath your car drains fluid and replaces it with fresh fluid that will turn black in 3 weeks because the surfaces inside your engine are coated in the contamination that the drain cannot touch. You are the person who understands that the problem was never the oil. The problem was always the surface underneath it. And the solution has been sitting on a shelf for 7 decades, waiting for you to pick it up. Now you know. Subscribe if you're not subscribed. Hit the bell so the next video reaches you before it gets flagged. Share this with every driver you know who has been told their engine is dying when it is actually just dirty. Every share is one more engine that runs clean on $2 instead of dying dirty on $4,500. The next video opens something even older. The transmission fluid compound they stopped selling in 1961 that eliminated the single most common automatic transmission failure mode, and why every transmission shop in this country still rebuilds units that a $3 treatment would have saved. You were never supposed to see any of this. Now you have. Drive accordingly.